In this video we are going to learn about the nuclear power plant. Nuclear power plant has the following major parts: nuclear reactor, heat exchanger, or steam generator, steam turbine, condenser. Nuclear reactors are the modern-day devices extensively used for power generation, as the traditional fossil fuels like coal are at the breach of extinction. The containment building where the nuclear reactor is housed is made of meters-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. One of the important components of a nuclear power plant that is a pressurized water reactor, or PWR. The nuclear reaction and the associated release of thermal energy takes place in a pressurized water reactor. Inside the PWR, fuel assemblies are mounted. The nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium. The nuclear reactor consists of three crucial components: moderator, control rods, and fuel elements. The fuel elements come usually in the shape of thin rods which contain fissionable nuclei like uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. In large power reactors, thousands of fuel elements are placed close to each other. This region where these fuel elements are placed is called the reactor core. These fuel elements are normally immersed in water, which acts as a moderator. The objective of a moderator is to slow down the energy producing during the nuclear fission process by the fuel elements. Thermal neutrons, which are the neutrons with energy of about 0.04 electron volts, are capable of producing fission reaction with uranium-235. During the fission reaction process, new neutrons are given out which have energies of about 1 MeV, that is 1 megaelectron volts. These neutrons typically escape from the fission reaction, participate in another fission process, as they are accompanied by enormous energy. In fact, the probability of these neutrons produce another fission reaction is 500 times less than that compared to a thermal neutron. This is where a moderator is extremely useful. Moderators have the capability to slow down, or in other words moderate, the speeds of these high-energy neutrons. This in turn can be used for a chain reaction to trigger multiple fission reactions of other uranium-235 nuclei. Commonly, ordinary or heavy water is used as a moderator in nuclear reactors because of the deuterons present in them, which are capable of slowing down the neutron's speed. The third and most prominent part of a nuclear reactor are the control rods. In order to get a steady output of energy from the nuclear reactor, every single fission reaction should trigger another fission reaction and ensure the availability of spare neutrons. Released to trigger the chain reactions by controlling the number of spare neutrons available at any given time. The rate of nuclear fission chain reactions can be controlled. This control on the fission reaction can be maintained using control rods. The main function of the control rods is to absorb any excess or spare neutron in the moderator in order to prevent any further fission reactions. Usually such control rods are made of boron or cadmium. To increase the rate of fission reactions, these rods can be removed from the moderator. A steady output of energy must be maintained by inserting or removing the control rods in the nuclear reactor. While making nuclear fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going inside the vessel. The water is heated to over 570 degrees Fahrenheit, but it does not boil, however, since the pressurizer maintains the water pressure constant at very high level. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes, so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building, which first drives a high-pressure turbine, and then is typically fed to two low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity. The water needed for this often comes from an adjacent river or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. Today we have taught about the basics of a nuclear power plant. Post your valuable comments and suggestions for improving the video. Thanks.